Now we have studied all the quantities in rotational motion. We have seen equivalence. Now application. Coming to application, we have so far seen linear motion. We have also seen rotational motion. Now see the difference. Here is a pulley. It is fixed and I rotate it, it moves like this. This motion is a pure rotational motion. Motion of the pulley is a pure rotational motion. I have a box on the floor. This is the floor, this is the box, and this is moving this way. Motion of this box is a linear motion. This is linear or translatory motion. Now, I have a wheel here. This is a motorcycle wheel and it is going on this road. What type of motion is it? It is going straight. What do you call it? Which type of motion? Okay. Is it rotating or not? Is it going straight or not? So what is the name of this motion? This is known as rolling motion. What is the name? It has got rotational as well as going straight. This is rolling motion. So rolling motion is combination of linear motion as well as rotational motion. This is something. Now any object which is rolling, we have to apply our knowledge of all the things of linear as well as angular. Number one, how much is the displacement in one rotation? Answer: in one rotation displacement is 2 pi r. That is clear? 2 pi r. Right. Velocity. If this velocity is v, what is the angular velocity? Yes, you know, v is equal to r omega, omega is equal to v upon r. So angular velocity is how much? R. Yes. Okay. The same goes for acceleration. But we come to the other quantities now. What are the other quantities? We should have discussed there itself. So far we have discussed the definition. After that we have studied momentum, we have done. Okay, force, torque we have done. What is left? Yes, energy is left. If a body is moving and making a rotational motion, how much energy it has? Without energy it cannot move. The particles are moving, having velocity, so it has kinetic energy. What is the kinetic energy of a rotating body? For any particle, the kinetic energy is equal to half. It's very easy. V is equal to r omega. So this will become now these are angular terms. So in linear terms it is mv square, in angular term it is I omega square. This is inertia, inertia. Velocity, velocity. Same. So this is kinetic energy of a rotating body. Now please come back to rolling motion. In the rolling motion there are two: linear motion as well as rotational motion. So this body has got both type of energies, angular as well as linear. So if I ask you that it has got a particular value of omega given, m r omega, find out kinetic energy. How can we find out energy with help of this? There are two types of motions. Yes, anybody? Kinetic energy of a rolling object. A rolling object has two types of kinetic energy. We call it kinetic energy of linear motion plus kinetic energy of rotational motion. Kinetic energy of linear motion. I omega c. This is the total kinetic energy of a rolling body, please remember. Right? Now you can tell me one thing. I give 100 joule energy to this. I give 100 joule energy to this. Ask them to roll. This is rolling. This is also rolling. In which case omega will be more? Which will be moving faster? This or this? I have given, no, not small, both have same radius. Same radius. This is R and this is also R. Pulley will have larger omega. Why? Yeah, understand it very well. I have given them 100 joule. All the 100 joule is used in here. 100 joule, first it will divide into 2 and one part of that will be used for rotation, so that has to be less. Understand? So whenever a motion is combined, the angular velocity become less. Clear? Okay. So this is rolling. Now if the whole energy, I just turn my question, and this is important. I have a wheel in my hand. I leave it from there. It falls down. It has certain acceleration, certain velocity because of G. I have given it energy equal to mgh. That mgh converts into kinetic energy. Suppose that is 100 joule. Now what happens? This wheel I make a yo-yo, and now I leave that yo-yo from here. It rolls and goes to the ground. It has certain angular velocity. Will that angular velocity? No. It has angular velocity as well as velocity to fall down. It is also falling down to earth. If I leave it, it is falling down to earth. Which will be faster? A freely falling or a yo-yo which is falling? Why yo-yo will not? I am not obstructing it. It can open as much as it wants. Why yo-yo has to be slow? Falling down. Linear velocity for both. Why it should be less? Why not same? Or is it same? So complete it. You are right, but complete it. You see, when I make this body loose and it is falling, how much energy I have given it? mgh, 100 joule. Yo-yo, I leave. I give it 100 joule. Both. This 100 joule, it falls down. Which type of motion it has and which it is not having? Linear. No? Whole energy is used for? You got the answer? First it will divide the energy, use it for two type of motions. One is rotational and one is linear. So some part it will consume in rotation. That is what you said. Some energy is consumed in rotation, and that for the rest of the energy it will fall down. So its velocity will be less. How much will be that? That is yo-yo problem. I was telling you, to find this velocity is known as yo-yo problem. Every student does it. You will also do it. Okay. So this is partition of energy when the things are moving. Another thing, if we want to find out energy of a rolling object, finding energy of a rolling object, it is very easy thing, because if m and v are given to us, what we can find out? Yes, kinetic energy of linear motion, half mv square. But if it is rolling, then we always have a relation to convert v into omega, and that r square V square R square will make M as I. So we have the formula for I omega that will give us the energy of rotation. So whenever we are asked, there will be questions where we are asked to find out energy. So we are supposed to find out the sum of energy, linear energy as well as rotational energy. And any one data is good for us. If V is given, R is given, we will not ask for omega. If M is given, R is given, we will not ask for I is given. So we can always convert it. Okay, some example will come, I will not create it here. So that we can always do. What we are going to do here is the problem, that is yo-yo problem. Yo-yo is a Western game, so they call it yo-yo problem. In our town, we call it a bucket problem. What is the bucket problem? Okay, in a well, you see, there is a well. In the well, we put a bucket. Here, here is the bucket. For water, we put the bucket, listen, here is the bucket, drop the bucket. It will go with certain acceleration, that acceleration is 9.8. You all know? G. Now, we put it with a rope along the pulley and you leave the rope. Okay, this is a long rope and you leave it. What will happen? Again the bucket will fall down. Will it be same acceleration? Why? Bucket is not rotating. Pulley is rotating, and that rotational energy, it is drawing from the energy of the bucket. So the speed of the bucket will come. Yes, the acceleration will change. Same principle. Some energy is used for rotation, like in yo-yo problem. So in Indian books, you will find this example. In Western books, Resnick, Halliday or other books, you will find yo-yo problem. It is one and the same thing. That some energy is used for rotation, then what will be the resultant acceleration? Let's do it fast. It is a very small calculation. It has got mass m. Here is a pulley. It has got mass m, I. We know in the free fall it was having acceleration equal to g. Now in this case we have left it and this is rotating. This is rotating with, say, angular acceleration alpha. We have to find out, this is falling down. We want to find out its linear acceleration A. If it is freely falling, how much is acceleration? 9.8. Now how much is acceleration? We want to find out. And that is the calculation you have to do. Now remember it. This radius is R. Here is this force working on it, and this is force is how much? Tension. We know this is tension and this is tension here. Okay. Now make a free body diagram here. How much is the force acting downward? mg. How much acting upward? T. mg is greater, that's why it is going down. So this is equal to linear acceleration A. Is this correct? And this is the A we want to find out. So A is equal to, anyway, let's keep it like this. mg minus T is equal to ma. One equation. Come here. This is radius r. This is tension T. So I request you to find out torque applied on it. Why? Because we have two formulas of torque. That is the reason. What are the two relations? I into alpha. That is torque. What is the other relation? Force into radius. F into R or R into F. There is one and the same thing. Okay. I alpha is equal to F into R. Then here, this is what? Torque. Because of this, we can always find out value of alpha. Okay. I alpha is equal to, what is the force? T. Into. What is T equal to? Right? Alpha. Now, T is something we want to get rid of. Unknown quantity. That is why we make two equations of T. If we add the two, the T is eliminated. Okay. You can add it at any stage. Let us add it right now. By 1 and 2, adding the 2, what we get? mg is equal to ma plus. Now, what we want to find out? A. What we do not want? Alpha. Please convert it to A. A by R. So what it will become? I. What is this I? Moment of inertia. Whose moment of inertia? Yes, remember. Moment of inertia because the rotating body is pulley. Right. What is this M? Mass of what? Yes, remember that. This is mg. What we want to find out? A. So, isolate A. You got the formula? A. M plus mg. Am I correct? Okay. Find out A. Pardon? No, I put it this way, mg upon this whole bracket. And this bracket is this is what you were telling? Yes, mr square plus I upon r square. That goes here and mr square plus I goes here. This. No, I don't like it. Make it more simplified. Divide numerator and denominator with mr square. Now how much it will be? That is problem with me. I don't remember. Never. I have done it hundreds of times. But every time I do the full thing and then I reach the solution. Anyway, this is the one. Now here, why we put it in this format? Because we want, please listen, when we leave the bucket without rope, what is the acceleration? G. With the rope, this is the acceleration. Is it less than G or more than G? Less than G. How do you know? Divided by anything. Yes, you are right. The denominator is more than 1. So it is less than G. Therefore, it is sure that this acceleration is less than G. Is it clear? Whose M is this? Bucket. This is I for Pulling. Okay, now I tell you a very small thing, which is a very minute thing, but if I would have been an examiner somewhere, the students might have been confused. I will ask that question. If it is a yo-yo, then what is the thing which is falling in place of bucket? Yo-yo itself. What is the body which is rotating in place of pulley? Yo-yo itself. In that case, this I is equal to half mr square, because yo-yo is a disk. That m and this m, same? Cancel out? So I write here for yo-yo. Please find out A is equal to how much? So smart, nobody needs to write. Do it. Orally do it. Pardon? 2g by, 2 upon 3. Is it okay? So you have solved yo-yo problem. What is the acceleration of a yo-yo? 2 by 3 g. What is the acceleration of the bucket? This. This is Indian problem. This is American problem. Which is more difficult? Right. Okay, whatever. But now you know the difference between the two. And both the things you will find in the books. And now you can differentiate. What is the difference between them? Right? So this is something. And related to this, there is another derivation. I will not do the derivation. It is all in the same line. We will simply see the solution. This is a body which is rolling down. And this angle is alpha. How much is the force bringing it in this direction? mg sine alpha. What is the acceleration part? G sine alpha. So what will be its acceleration? Same. Sine alpha. Right? So please write down. Make this example. Title: a body rolling down and inclined. Body rolling down and inclined. This is the acceleration of a body which is rolling down at an angle alpha. The numericals are asked for this, not for this. Have you written it? Okay, let's make it fast. Let the angle be 30 degree. How much is sine 30? Okay, you all know. Now, what is this m belongs to? The body which is rolling. And this I also belongs to same body, like yo-yo. Correct? So it is that yo-yo problem. Now, I ask you, please write what comes in the examination. A sphere, write down, hollow sphere, disc, a hollow sphere, a disc, and a cylinder. Hollow sphere, a disc, and a cylinder. All three having same mass and radius are rolling down the incline. Rolling down the incline. Which will reach the bottom faster. Which will reach the bottom faster or earlier. So answer is the one which will reach earlier will be the one whose acceleration is largest, more. So you have to find out acceleration. Please go for this. Where will be the catch? That is all same. The catch will be here. For every one, you will have to put value of, that's all. And M will be cancelled. MR will be cancelled. Okay. Now find it and tell me. What is I for spherical shell? For disk? Hollow cylinder. Same as ring, because hollow cylinder is combination of so many rings. Pardon? Cylinder is the one which will reach first. Moment of inertia for hollow cylinder is mr square. Mr square. Pardon? For hollow cylinder, it is mr square. For solid cylinder, it is mr square upon 2. You see, hollow cylinder and ring have the same moment of inertia. Solid cylinder, if you cut the solid cylinder, what do you get? So many discs. So that is formula for the disc. If hollow cylinder you cut, what do you get? So many rings. So that is ring formula. Yes, hurry up, इतना time क्यों लग रहा है? These are the things you should do orally. Hollow cylinder what? Reaches? My God. अरे उसको उल्टा करिए. Which one will reach first? Okay, no, you tell me acceleration. For this, how much you get? Oh, decimal आ गया बीच में. चल. 3 by? For this? This is 3 by 1 upon 2. Now this, which is the larger? Disc is the largest. This A is larger, smaller than this, and this is smallest. Correct? Third. So this is ratio of their acceleration. Which is the fastest? Which will reach down first? Disc. So whose moment of inertia is least? That is reaching first. That is disc. With how much acceleration? This. So is it clear? So you can always find out. This is some principle on which the questions are asked. Right? So we have done almost everything, and now we are in a position to do the questions.